All right, let's find the distance from a point to a plane. Okay, so anytime we're doing the distance from a point to a plane, we can use this formula. So we're going to have a point in the plane P and a point off the plane Q. We're going to dot that with the plane's normal vector and then divide by the magnitude of that normal vector. So we need to find just any point on the plane. It doesn't matter what we choose. So it's usually easiest to just set two of the variables equal to 0 and get what the point would be. So let's set x and z equal to 0 as an example. So 0 comma something comma 0. We just need to figure out what y is if x and z are both 0. And you can find that y would have to be negative 4. Okay, you could choose any point that works for this plane, but this one is going to be pretty easy to work with. We know what our point Q is. It's 6, negative 2, and 4. So now we need this vector PQ. So the way we get that is just do final minus initial and subtract those components. So we're going to get 6, 2, and 4 when we do that. Now what we also need is the normal vector because we have to do the dot product with it. So the normal vector we get from the equation of the plane. With the form that it's in, the normal vector is just going to be the components or the coefficients of x, y, and z. So it's going to be 2, negative 1, and 2 for our case. So now we need the absolute value of PQ dotted with n, right? And this is going to give me 12 minus 2 plus 8. It's still an absolute value, but that's going to be a positive number, and it's going to be 18. Okay, now the only other thing that we need for the distance is the magnitude of the normal vector. So the magnitude of the normal vector is the square root of 2 squared plus negative 1 squared plus 2 squared, which is the square root of 9, which is equal to 3. So now we have all of the information that we need. So we get that the distance is equal to 18 over 3, which is equal to 6 units. So this is the distance from that point to the plane.